communication satellites. In this book from the 1970s, some things are said about it. And they are said that they can transmit or broadcast telex or TV or telephone signals. And they are said that they have some advantages. They don't need all the expensive cables. And they are orbiting around the Earth, geostationary. That means that they're all the time above the same place on the Earth. They are turning in the same speed as the Earth is turning in 24 hours around the Earth. So they're always at the same space around the Earth. In 35,680 kilometers over the Earth. And the first one was in 1962 at Telstar. And another one would be Intelsat, and that Intelsat that can broadcast simultaneously 9,000 telephone conversations. And they cover 1/3 of the Earth, such a one, in that height of 35,680 kilometers. So if someone would be not calling from New York, London, but a bit further away over to Shanghai, then it would go over a second satellite over. That would be a bit more difficult, but it would work. And that is according to the Reader's Digest Library of Modern Knowledge, Book 1, Part 1, Structure of Universe, written by Ian Rilpath and Jonas Shakespeare, on the pages 52 and 53. But the positions and views expressed in the source of ones of the source and don't necessarily align with my own or the ones of the entity spoken of. I'm Rebecca. I'm trying to learn mechanical engineering. Today, communications satellite. And after we've done the break, we're gonna do. Did I just say it wrong? After that, we're gonna do leg engineering. So, communication satellite. That is a satellite that relays telephone, telex, and TV transmissions between ground stations on Earth. The book is from the 1970s. Okay, a satellite is something which relays telephone, telex, and TV transmissions between ground stations on Earth. I don't know what telex is, and I don't know what relays means. But the first active commercial communications satellite was Telstar in 1962. Telstar was the first one in 1962. Communications satellite. Communications satellites, ComSats, eliminate the need for expensive cables or chains of radio relay stations. So first, communication satellites could be shortened to ComSats. Communication satellites, ComSats. And they don't need the expensive cables or of chains which radio relay stations need. What cables do radios need? Are radio not also? Or is that through the satellites? Are these radios before the 1960s also used with cables like a telephone? Okay, we don't know. We know that it eliminates the cost of laying expensive cables. Because the satellite can link any 2 points on Earth that are visible from the satellite, it is more flexible than conventional long-distance communications links. And it can, I don't really know what it means, but it can reach a great area. It can reach everything it can see from space, or that is almost half the Earth or something, or third or quarter of the Earth. It's very big. Modern ComSats receive transmissions from ground stations, amplify them, and rebroadcast them back to Earth. So on the Earth, a ground station is sending something that is amplified in the communication satellite and then rebroadcasted back to the Earth, everywhere where the satellite is reaching to, which are thousands of kilometers. The latest ComSat, called Intelsat, can carry up to 9,000 simultaneous telephone conversations. Can the one satellite then send to 9,000 different ones? But the book is written in the 1970s. Do they mean mobile telephone? They don't mean mobile telephone or mobile phone. But how is now a satellite necessary if phone is not also going over these phone lines? And why would it be an advantage in the 60s or 70s to reach 9,000 telephones if they're all going over these landlines? We understand the thing which we said. It can simultaneously carry or broadcast 9,000 telephone conversations. Each communication satellite in orbit 35,680 kilometers above the Earth's equator, takes 24 hours to circle the Earth. The same time as the Earth takes to spin once on its axis. Are we satellites circling the Earth, or are we satellites standing where the Earth is turning? Now, the satellites are turning with the Earth. But if they are turning with the Earth, are we not always above the same position? Or is it even intended? Are the satellites which are faster? The ISS goes around in 2 hours, I think. How would the speed which a satellite is going around the Earth be adjusted? My idea is, so I heard the following, that a satellite is basically constantly falling down to the Earth because it's not with fine space, or that it's out of the gravitation field of the Earth. It's constantly falling out, but it's at the same time moving further, so it's the whole time falling around the Earth. What if that satellite would be 10, 15, 20 kilometers closer to the Earth, and then it would be faster falling, and it would turn faster around the Earth? You could say with all words, I have no idea how it works. But I think that's an interesting thought. Okay, we know these communication satellites are 35,680 kilometers above the Earth's equator. Are they all around the equator? They are around over the Earth. We're going to say Earth. If it's when the equator, we are on the safe side still. But if it's not always the equator, then we are also on the safe side. And it takes 24 hours to circle the Earth, the same time as the Earth takes to spin once on its axis. Relative to the Earth, the communication satellites therefore appears to be stationary. Okay, as if they would be stationary, so they're turning the whole time over the same place on the Earth. At the same time, all the time, at the same time in the sky. This is called a geostationary or synchronous orbit. Okay, and that type of orbiting, that we're every time at the same place above the Earth and turning with the Earth, is called geostationary or synchronous orbit. Each satellite can see approximately 1/3 of the Earth, so 1/3. Hence, a message relayed to the opposite side of the Earth may have to go through more than one ComSat. Okay, and if someone is phoning from New York, someone in London, that would work if there's one satellite somewhere in the middle of the Atlantic Ocean. That would be not even 1/3 of the Earth. But if someone from New York would call someone in Shanghai, that would need an additional satellite. So the first satellite in the Atlantic and another one went over Moscow somewhere, and then the other one in Shanghai. Okay, am I able to say these informations? They are relaying. They are relaying, for example, telephone or telex or TV transmissions. And the first active commercial communication satellite was Telstar, which started to do Telstar in 1962. Communication satellites could be shortened down to ComSat, and they don't need all these expensive cables. More flexible than conventional long-distance communication links. And they can reach quite a big part of the Earth, it's also an advantage. And they can simultaneously broadcast 9,000 telephone conversations, orbiting 35,680 kilometers over the Earth. And they are geostationary and synchronous orbiting. That means that they're all the time at the same time above the Earth. They're covering around 1/3 of the Earth, one of them. The latest Intelsat could, for example, do 9,000. And we're going 1/3 at the time, 1/3 of the Earth, going with the Earth. And if it would go to the other side, a bit more. Okay, let's start to do it. Telephone, telex, TV transmissions. Telstar. Intelsat. Communication satellites. In this book from the 1970s, a few things are said. And they are said that they can be used to transmit television or radio or Telsat things. And now what was the thing? Telex. Telephone, TV, telex. Communication satellites. In this book from the 1970s, a few things are said. They said that they can transmit telex or telephone. What radio was it? That's TV and telephone. communication satellites. In this book from the 1970s, some things are said about it. And they are said that they can transmit or broadcast telex or TV or telephone signals. And they are said that they have some advantages. They don't need all the expensive cables. And they are orbiting around the Earth, geostationary. That means that they're all the time above the same place on the Earth. They are turning in the same speed as the Earth is turning in 24 hours around the Earth. So they're always at the same space around the Earth. In 35,680 kilometers over the Earth. And the first one was 1962 Telstar. And another one would be Intelsat, and that Intelsat that can broadcast simultaneously 9,000 telephone conversations. And they cover 1/3 of the Earth, such a one, in that height of 35,680 kilometers. So if someone would be not calling from New York, London, but a bit further away over to Shanghai, then it would go over a second satellite over. It would be a bit more difficult, but it would work. And that is according to the Reader's Digest Library of Modern Knowledge, Book 1, Part 1, Structure of Universe, written by Ian Ridpath and Jonas Shakespeare on the pages 52 and 53. But the positions and views expressed in the source of ones of the source and don't necessarily align with my own or the ones of the entity spoken of. That was the mechanical engineering part. What did I forget? Not that much. I think I said it all. That was the mechanical engineering part. If you are here for mechanical engineering, you can go directly to the next part of mechanical engineering, where we will continue with mechanical engineering. If you stay here and participate in leg injury prevention training, then is that at your own risk. Have a good standing leg and swing the other leg in front to the side. And the other foot in front and to the side. And one foot in front and back. And the other foot in front and back. And one leg up. Over to the side, breathe in. Middle, down, other leg up. To the side, breathe in. Middle and down. One leg up, arms up. And over cross. Middle, down, cross. Middle and down. Our leg up, over cross. Middle and over cross. Middle and down. And one leg to the side. Lift off the ground, place it again onto the ground. Try to move only with the leg, not with the hip. Other leg. One hand on tummy, one on lower back, and lift one leg up in a straight line, pull the toes in and try to bring the leg higher up. And pull it up. Other leg up. Control with the hands but you don't fall back. Try to bring the leg higher, pull the toes in. Pull the leg up. And have a good, first one leg up. And press with the knee up. To the side. With the other leg up and to the side. Have a good standing leg and turn over to that leg. Go down, turn over again and come up. Change the leg, stand good, turn over, down into the knee, turn, come to the road over, up again. Have a good standing leg and reach always with the heel of a mobile leg to imaginary 90-minute intervals of an imaginary dial. Other foot, 12 o'clock, 1:30, 3, 10:30 and 9 o'clock, 7:30 and 6 o'clock, 4:30 and 3 o'clock. And one heel onto the ground, don't do it if you're pregnant, lift the heel off the ground, place it again onto the ground. Our heel onto the ground, lift the heel off the ground, place it again onto the ground. And one leg up and down. And the other leg up and down. And now staying good on one leg, the other leg up, and bringing it high up. And down again. And another time. Leg up and pull it in and out. And down with the other leg. Out. Or up and down. And now pull it in and out. Back into the leg. Legs a bit to the side, breathe in the arms up. Breathe out, sink down, hands onto the ground, come around, back up, slowly upwards. Backward shoulder roll, in the arms up. Out, sink down, hands onto the ground, come back up, around, slowly around, back up, and to the backward shoulder roll. Have legs wide standing apart, breathe in down. And out. In and up. And out. In and close the legs. And out. It was the leg injury prevention training. I thank you very much and until next time.